Hi, and welcome to today's video where today we are going to be looking at something called Pythagorean theorem. And essentially what we're going to be doing is we are going to be looking at how to determine the length of this long line on a right angle triangle. This long angle line has the name called the hypotenuse, and the hypotenuse is always going to be the longest line on a triangle. So essentially if I took this line and I stretched this out, you would see that this line would be longer than this. So mathematically, that is telling me that I know that I'm going to be something bigger than 4 meters. Before we get into it, by all means, go smash that subscription button, go hit the like button. Let's get started. So, the first thing that we need to know when we're doing this is that there is a little bit of a formula that's been around for about 1,000 years now by a gentleman by the name of Pythagorean, and he has determined that if we were to take this line right here and square this, so if this was a true square, this 3 meters would be the same as this. And if we solved what this area was, we would end up with 9 meters. 3 times 3 is 9. Now you might be thinking to yourself, okay, well why are we doing this? This doesn't make any sense to us. It will in a second. We're going to do the exact same thing over here, where we're going to take a line that is 4 meters, and we're going to square it also. Let's assume that that is a true square size right there. It's probably not, but this is 4 meters, and if it's a true square, then this would be 4 meters as well. 4 times 4 is 16. Meters squared. Meters squared. Now, what Pythagorean was able to determine was that this, on a right angle triangle, if we took this area and we added them both together, we would actually get this area right here if it was squared. Which means that the length of this line would be the length of this line, and we still don't know what this is. So we're going to label this c squared. So let's think about this formula right now. What we have here is we've got a, b, and c. And the formula that you're going to need to use is this. A squared plus b squared is equal to c squared. This is Pythagorean's formula, his theorem. So let's think about this. If we're looking at this logically and mathematically, if a squared is 9 and b squared is 16, then a squared and b squared added together would be equal to 25. 25 meters squared. Let's plug in those numbers and just make sure here. So let me jump back into, did I have green? If I had 3 squared plus 4 squared, it's going to be equal to c squared. 3 times 3 is 9, plus 4 times 4, which is 16. It's going to be equal to c squared. 9 plus 16 is 25, is c squared. Okay, so you're thinking to yourself, okay, great. I've got an area of a square, an area of a square, and an area of a square. How does that help me? Well, here's the thing. In mathematics, if we have a square, we actually can use a mathematical operation, a relatively simple mathematical operation, in order to figure out the square root. And if you're not familiar with what a square root is the length of one line times itself to equal an area, because we were talking about perfect squares. So think back to this. If this is 3, and this is a perfect square, it means the other line has to be 3, has to be 3, has to be 3. 3 is going to be the square root of 9, because 3 times itself gives me this area. If we look at this one, what we have here is we've got an area of 16 meters squared. So what two numbers, identical numbers, when multiplied together are going to give me this perfect square? Well, that would be 4 times 4. So let's work backwards here. If we've got 25 meters squared as our area inside of here, I need to know what number times itself is going to give me this. Well, in math, there is a real quick button on your calculator called the square root button. And it's going to give you that number. So it looks like this. The sign itself looks like this. Now, a lot of people might look at that and say, oh, that looks like long division. It is not the long division button. There is no long division button on a calculator. The button on a calculator that looks like division is the division button. So if we were to take 25 and square root it, then what we would have here is we've got c is equal to the square root of 25. And that would mean that if we hit this button, c is equal to 5. 5, in this case, meters. Because 5 times 5 gives me 25. So we have a perfect square. The length of this line multiplied by a perfect square, the length of that line, the identical number, is going to give me the squared number. So we know by solving the area of this plus the area of this is going to be equal to the area of that. Then we just square root that number. It's going to give us our missing length. So here's one of the things that does not happen very often, though. The whole working backward process. Let's say that we did not have this. Let's say I'm going to get rid of this for a second. Maybe this becomes our unknown. We're looking for a. Let's say we know what this is, and we know the length of this. So we know that 5 and 4 are our numbers that we're going to use for this. But we're going to work backwards. If this is our formula to work forward to solve for the hypotenuse, then we're going to use this formula to work backwards. We're going to have a as our missing number. A squared is equal to what we know, c squared minus b squared is going to equal a squared. And then we can just plug in the numbers that we know. A squared we don't know is equal to c squared. C is 5 squared minus 4 squared. A squared is equal to 5 times 5, which is 25. Remember, it's squared. It's not 5 times 2, which a lot of kids make mistakes with. Minus 4 squared, which is 16. That means that a squared is equal to 25 minus 16, which was 9. In order for me to determine the length of the line, I still need to use that square root button. So I have a is equal to the square root of 9. A is going to give me a value of 3 meters. The length of this line right here is 3 meters. So what you can see here that we've done is we've worked forward, figured out the area of these shapes plus these shapes added together. We've worked backwards. We used this shape minus this shape to give us this shape. So there is a relationship between all of these squares when added or subtracted to help us determine maybe unknowns that we don't quite know. This essentially is Pythagorean theorem. What I would invite you to do is go back, rewatch the video if something isn't making sense. Maybe drop a comment down below on any questions that you might have so I can help you further if it warrants another video. And don't forget to like and subscribe. And that's Pythagorean theorem in a nutshell, guys. A squared plus b squared is c squared, or working backwards, a squared or b squared minus is equal to a squared or b squared is equal to c squared minus a or b squared in order to figure out the missing variable. All you need to do is just plug in the numbers and that should work. Okay, thanks very much for watching. We'll catch you on the next video. See ya.